Hey everybody. So I want to go over your pre-test um, practice problems with you in video format since I will not see you on Wednesday. So let's go over these problems real quick. Okay, question number 1 is going to be a simple multiplication problem. Please remember that when we multiply radicals, we want to multiply both the coefficients and we want to multiply the radicands and then simplify. So here I'm going to go ahead and multiply 3 times -1, which gives me -3. And then I'm going to multiply the square root of 2 times the square root of 2, which is going to give me 2. So I end up with -3 times 2, which gives me -6. Okay? So look at the question number 2 is a simple subtraction problem. Please remember that you can only subtract radicals that have the same radicands. Okay, so I have a positive square root of 3 and I have -4 the square root of 3, which means that I have -3 the square root of 3. You can think of this as you have one apple and you want to take that away from your -4 apples, which gives you -3 apples. And we have nothing to combine with our -4, so we just bring it down. And so there is your answer. Okay? So let's look at number 3. Number 3 says that we want 2 to the square root of 5 raised to the third power. Okay? So this is going to mean 2 to the square root of 5 times 2 to the square root of 5 times 2 to the square root of 5. Okay? So if you want to do this the long way, you can write it out like I just did. And we get 2 times 2 times 2 gives me 8. We have the square root of 5 times the square root of 5 gives me 5. And then we have 1 square root of 5 left over. 8 times 5 is 40. So we end up with 40 to the square root of 5. Okay? Here we go with number 4. On number 4, we cannot do the square root of a mixed number. So we need to change this into an improper fraction, which I cannot stand that word, but we're going to change it into a fraction. 8 times 9 is 72, plus 1 gives me 73 over 9. And one of the rules that we learned in this unit is that when we have a fraction underneath a radical sign, that we can rewrite that as the square root of 73 over the square root of 9. Okay? Well, the square root of, there is no square root of 73, so we can leave this as the square root of 3, or 73, and the square root of 9 is 3. And so we have now simplified this. Okay, let's look at number 5. Again, we have a fraction underneath one radical sign. So we're going to rewrite this as the square root of 3 over the square root of 64. The square root of 3 has no square root, so I'm going to leave it as the square root of 3. The square root of 64 is 8. And so our answer is 3, square root of 3 over 8. Here we go, number 6. We're being asked to simplify this. The square root of 12. You can either do the prime factorization method or you can do the perfect square method. Let's do the real short method, which is the perfect square. That one says that I can rewrite this as the square root of 4 times the square root of 3. Well, the square root of 4 is 2, so I end up with 2 to the square root of 3. You can do that method, or you can do the prime factorization method. So I'm going to break 12 down into all of its prime factors. 2 times 6, 2 times 3. I'm going to go ahead and build my radical sign. Only the pairs can go outside and play, and only 3 can stay inside. Either method gives you the same answer. Okay, let's look at the square root of 142. Okay, this one's going to be a little bit harder, so I'm going to go ahead and try the prime factorization method. So I'm going to go 142. I'm going to break it down into 2 times 71. Okay, so 71 is a prime number. So there are no perfect squares in this one. So this is in its simplest form. So your answer is the square root of 142. Okay, everybody good? Number 8. Okay, and number 8, the very first thing we need to do is we need to distribute this -3 to both of these problems. Okay, so we're going to end up with this cube root of 3 minus 3, and -3 times this is going to give me positive 3, the square root of 3. Remember, we can only combine terms that have the same radicands. So I have 1 square root of 3 plus 3 square root of 3 gives me 4 the square root of 3. And I'm going to bring my -3 down. And there is my answer. Okay? Number 9. Again, we're going to do the distributive property. But this time our radicand has a coefficient with it. So 3 the square root of 5 times 2 gives me 6 the square root of 5. 3 the square root of 3 the square root of 5 times negative square root of 5 is going to give me a negative 3 times 5. So here we're going to end up with 6 the square root of 5 minus 15. Okay? Here we go. Now we have a perfect square. So if you want to, you can either FOIL this, or what we call the double distribution property, or you can use your special formula that we learned, a squared minus 2ab plus b squared. Okay, so I'm going to use this one, okay, and then I'll FOIL it for you. Okay, so my a is 3, so I'm going to have 3 squared. Okay, so my a is 3, my b is negative the square root of 3 times 2 is going to give me negative 6 the square root of 3. And then the square root of 3 times the square root of 3 just gives me 3. So now 3 squared is going to give me 9. So now I can combine 9 and 3, which gives me 12 minus 6 the square root of 3. Okay? Everybody good? So let's do number 11. Number 11, again, is going to be a double distribution property, or as we say, FOIL, or you can do the Punnett Square. I prefer the Punnett Square, so I'm going to go ahead and do the Punnett Square. So I have 2 the square root of 3 plus the square root of 2 times 2 the square root of 2 minus the square root of 3. Okay, so now we're going to do a little bit of multiplication. 2 the square root of 2 times 2 the square root of 3 gives me 4 the square root of 6. 2 the square root of 2 times the square root of 2 gives me 4. Negative the square root of 3 times 2 the square root of 3 is going to give me negative 6. And negative the square root of 3 times the square root of 2 gives me negative the square root of 6. And now I want to combine my like terms. So I have like terms here. Negative 6 and 4 give me negative 2. I have 4 square root of 6 minus 1 square root of 6, which gives me 3 the square root of 6. Okay? So here we go, number 12. With number 12, we need to simplify this. Please remember, one of the rules that we learned is that you cannot have a radical in your denominator. So I'm going to rationalize my denominator by multiplying my denominator over my denominator. Okay, so I have the square root of 6 is in my denominator. So I'm going to multiply the square root of 6 over the square root of 6. 2 times the square root of 6 gives me 2 the square root of 6. The square root of 6 times the square root of 6 gives me 6. Unfortunately, I'm not done because I can simplify 2/6, which gives me 1/3. So I'm going to end up with the square root of 6 over 3. And if you want to put the 1 there, you are welcome to do so. Okay? Here we go, number 13. Number 13, you are going to be multiplying by the conjugate. So let's look. We're going to go ahead and multiply the conjugate of 3 minus the square root of 2 is actually going to be 3 plus the square root of 2 over 3 plus the square root of 2. So now we're going to do our multiplication. Let's do the distributive property. The square root of 2 times 3 is going to be 3 the square root of 2. The square root of 2 times the square root of 2 is going to give me 2 over. Because this is the difference of two squares, we only have to deal with the two numbers. So I have this 3 times 3, which gives me 9. The square root of 2 times the square root of 2 just gives me 2. So I'm going to end up with 3, the square root of 2, plus 2 over 7. Okay? And so I am done with number 13. Let's look at number 14. 14 is just like number 13. We need to rationalize our denominator. So, we're going to do the conjugate of our denominator. So if we look at our denominator right now, is the square root of 3 plus 2. So our conjugate is going to be the square root of 3 minus 2. And so we're going to multiply both our numerator and my denominator by that conjugate. Okay, here we go. I'm going to do my denominator first. Square root of 3 times the square root of 3 gives me 3. Positive 2 times a negative 2 gives me negative 4. And now I'm going to FOIL. If you actually look at my numerators up here, you can FOIL it if you want. Punnett Square, I don't care. Or you can use one of the patterns that we learned. Okay, this happens to be a perfect square. So I'm going to go ahead and use that one. So I'm going to end up with 3 plus 4 minus 4 the square root of 3. Okay? And so now I need to combine some like terms. So this guy, 3 plus 4 is going to give me 7 minus 4 the square root of 3 over negative 1. And please remember, we learned that we cannot have a negative denominator, so we need to multiply through by negative 1 to change all of our answers, or all of our numbers in the numerator. So we're going to end up with negative 7 plus 4 the square root of 3. And that is going to be our solution. Okay? Everybody cool? Number 15. Again, we're going to need to multiply by our conjugate of our denominator. Our denominator is 2 plus the square root of 5, so we're going to do 2 minus the square root of 5. And because we're multiplying our denominator by that, we must multiply our numerator by that. So here we go. I'm going to do my denominator first. 2 times 2 gives me 4. Square root of 5 times the square root of 5 gives me 5. And now I'm going to FOIL my numerator. So if you would want me to, I'm going to do the Punnett Square because it seems to be the easiest for most of you. So I have 1 minus the cube root of 5 times 2 minus the square root of 5. 2 times 1 gives me 2. 2 times the square root of negative 5 gives me negative 2 the square root of 5. The negative square root of 5 and 1 gives me negative 1 the square root of 5. And negative the square root of 5 times the negative square root of 5 gives me 5. I'm going to combine my like terms. I have 2 plus 5, which gives me 7. I have negative square root of 5 and negative 2 the square root of 5, which gives me negative 3 the square root of 5. Okay? We're going to do a little math. I end up with 7 minus 3 the square root of 5 over negative 1. And as mentioned in the previous question, we cannot leave this over a negative 1. So we need to switch all of our signs in our numerator. And so here is our answer. And again, if you would like to leave this over 1, you are welcome to do so, but you do not have to do that. Okay? Number 16. Find the distance between 2 points given 1 comma the square root of 2 and 1 comma negative 3 the square root of 2. And I gave you a hint to use the distance formula. If you remember from when we learned the distance formula, the distance formula is d equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so let's look. This is going to be x1, y sub 1, x2, y sub 2. So let's go ahead and substitute in our numbers. Here we go. X sub 2 is 1, x sub 1 is 1 squared plus y2 is negative 3 the square root of 2 minus the square root of 2 squared. Well, 1 minus 1 is 0. 0 squared is 0. So I don't have to deal with that side of it. So let's look at our y's. Negative 3 the square root of 2 minus the square root of 2 gives me negative 4 the square root of 2. And that needs to be squared. And so I'm going to end up with 4 squared is 16. And that's going to give me the square root of 2 squared will give me 2. And so I end up with the square root of 32. And if you remember our rules, we need to simplify this. You can either simplify it by finding the perfect square, or you can do the prime factorization, and I'll do it both ways with you. We know that the perfect square in 32 is the square root of 16 times the square root of 2. The square root of 16 is 4, the square root of 2. If you want to do it the prime factorization method, you can go 2 times 16. 16 you can see is a perfect square already, or you can keep going. 2 times 8, 2 times 4, 2 times 2, and we are done. We go ahead and build our house. Only pairs of 2s can go outside. Here's another pair of 2s, and we have 1 2 left over. 2 times 2 is 4, so we end up with 4 the square root of 2, and we end up with the same answer either way that you want to do it. Okay, and that is our review on our pretest. Hopefully you have done this and you are prepared for your test on Thursday or Friday. Have a great day and take care of yourself.